Hello viewers, here is another example on geometric sequences or what we call geometric progressions. The general formula which you must learn and which you must know for calculating the nth term in a geometric sequence is AR to the power of n minus 1. So once again people, this gives you the term at any position. A is the first term, R is the ratio which we can calculate, and then N gives you a certain position in the sequence. Okay, this question now is determine which term in the sequence 2, 6, 18, 54, and so forth is equal to 162. So what we do first, we are going to identify all my variables, all right? So I always say ID the given information. All right. So now, in this case, people, they're asking you which term is equal to 162. So Tn is equal to 162. Then your first term easily is number 2. Then your ratio, remember, we calculate by taking a term divided by the previous term. So 6 divided by 2 equals 3. Or you could have taken 54, divide that by the previous term, which is 18. That also gives you a 3. So the common ratio is 3. All right. And if you now look at the question, it asks you which term. So therefore, n is being asked. All right. Then we start with our standard formula. And in step 1, we will now substitute the relevant numbers into their places. So this becomes 162 equals A is 2 times R is 3 to the power of n minus 1. Okay, and remember, we want to find what is n. So in this case, the first step is to move over the 2, which is multiplied here. So on that side, it will become divide by. So 162 divided by 2 gives me 81. And then on the right-hand side, I've got 3 to the power of n minus 1 left over. Okay, now this is now an exponential equation, which means you must solve that by either logs, okay, or by the exponential, the indices laws. Okay, I will now do that with an index law. So I will first get 81 into its prime factors. That you can do on the calculator, and it will give you 3 to the power of 4, and on the right hand side it remains 3 to the power of n minus 1. And remember, with the exponential equations, we learned that if x to the power of let me just make this another base. If a to the power of x equals a to the power of y, then I can also assume that x equals y. Okay, that's your exponential or the indices laws. So in this case, people, I can basically ignore the basis and I can say, therefore, 4 equals n minus 1. And now we still want to find n, which means we must move the 1 over to that side. It is negative, it becomes positive. So n equals 5. Right. So in the fifth position, 1, 2, 3, 4, in fact, the fifth position is the next position. Okay, we would find 162. So once again, people, you will just simply start by identifying your given information. Use all the variables of your standard formula, which is Tn, A, R, and N. identify those, then write your formula, substitute the values, okay, and then solve it algebraically. And in this case here, you can either solve it by exponential equations and their laws, which is this one, or you could also have done the log laws, all right, which I'm not going to explain in this video. All right, okay, I hope this helps. This is an example of the question where you have to find the position.